you're asking not necessarily asking the wrong question, but one of the people who absolutely needs to be in that room is the enterprise architect. When you're asking that question, why? Because you're making an enterprise architecture decision about the infrastructure, the fundamental underpinnings of everything that the enterprise architect is delivering.
Yeah.
And you should not be making that decision independently of where the enterprise architect is going.
Enterprise infrastructures are entering a turning point, now reshaped by artificial intelligence, uh, tested by the future of data centers, and also redefined by how leaders at the helm of these enterprises plan for the decade ahead. Hello, everyone. I'm Bilal, and I'm excited to welcome you to an episode that takes a very closer look at the forces that are now transforming the very foundations of enterprise technology. And to dive into this, I am thrilled to be joined by Tony Harvey, Vice President Analyst at Gartner. He's someone who has seen enterprise infrastructures from both sides, building systems at Cisco, Compaq, and Lenovo, and now advising CIOs and global leaders at Gartner. We will be diving into Gartner's AI frameworks, exploring the changing face of data centers, and spotlighting the signals that could make or break enterprise infrastructures for years to come. So, without further ado, let's dive right in. Tony, it's a pleasure to have you with us. Thank you so much for taking out the time to doing this.
Okay, no, thank you. Thank you for having me on the podcast. I'm more than happy to talk about where I come from, what I do, and talking about me. What else? What else could anybody ask for? You're going to get me very bored by the end of this, I can tell you.
I I am very optimistic I won't. All right, so starting off with, we would really like for your trajectory, career trajectory to be distilled, right? You've spent years in shipping enterprise systems, at Hewlett Packard Enterprises, Cisco, Lenovo, before moving into an advisory seat at
Mhm.
Gartner, right? That means you must have viewed the same problems, from both sides of the table, right? Building the product and then guiding executives on how to buy, deploy, and govern it as well, right? So first, take us through this very interesting career spanning nearly 4 decades, and if you have to name a single through line that explains your shift from product to advisory, what would it be?
Oh, that's an interesting question. Well, the last bit was the. So where did I come from? Well, as you can probably tell, I'm not a native to the US.
Hmm.
I'm originally from the UK, Southeast London. I went through a number of small companies in the IT space there that I don't even bother to list anymore. Um, Although it's weird, when every now and again I'll meet someone. Didn't you used to work at company X? Yes, I did. Oh my God, that's 50 years ago now. It's depressing. Um, I ended up working in the UK for a company known as Compaq at the time, who you may have heard of, Compaq Computer.
Yep.
From there, I was doing a bunch of stuff around product management in the European environment, which was somewhat different from product management from the US, because you're more focused on pricing and packaging as a regional product manager, where you're really, pricing competitive, working on looking at how the rest of the market is doing. How can I take, to a certain extent, what I've been given by the US and make it work for my market, and then feeding back what my market is telling me into the product teams in the US.
Yeah.
And then from there, obviously, I wanted to do the other side of it. Moved into the US, did some time on kind of tech marketing stuff,
Okay.
and then moved into product management for Compaq as was, which then became HPE. No, became HP, then became HPE. I think it might have become HPE actually after I left them. It all blurs together over time. But
Mhm.
so there I did product management originally on in the rack and power group, which was really interesting because that was the group where I learned everything I know from a bunch of really, really smart people around how data centers work, how power supplies work, how UPSs work, the importance of those products in the data center and environment. And I got to work with some really amazing engineers in that space,
Okay.
names in the data center world that, people like Christian Bellardi. I used to work with Christian Bellardi.
Okay.
He's the guy who built all the data centers for Microsoft. I used to work with Wade Vincent, who is now the lead engineer on power and cooling at NVIDIA. Um,
Okay.
that's the kind of really smart person I used to work with. And I wish I was as smart as them because, hey, I'd be Christian Bellardi or Wade Vincent. Unfortunately, I'm not. I'm not. I'm only okay. So, but yeah, the opportunity to learn from those kinds of people is really amazing. And I took that advantage when I was in the Rack and Power group. And Rack and Power was the reason kind of Rack and Power existed inside Compaq originally was we built this server, eventually became the DL360, which was a one-use server.
Okay.
And then we figured out we could put 42 one-use servers in a rack. And then we discovered nobody could deal with 42 one-use servers in a rack because the rack was too heavy, took
Yep.
too much power, and all of this stuff that was going on. These problems have always been around. So we
Mm.
had to figure out, how do we do this? How do you cable this up? What does it look like in the back from a power perspective of just physical power cables and networking cables? How do you do the cable management arms? All of that kind of stuff was being worked out by the teams in the rack and power group, which was how we learned all of this stuff.
Yeah.
Eventually, from there, HP or Compaq at the time had the P class blades and was moving into blade system, the C7000. And I started working on the C7000 stuff from a power and cooling perspective because, again, when you get to a chassis that can run 8 kilowatts by itself, that becomes a whole raft of other issues that you need to
Yeah.
think about power and cooling. And then we were looking any blade chassis, you kind of have to predict where the world's going to be in 10 years' time. Because if you're building a blade chassis, you have to be able to do two or three, possibly four or five generations of server inside that blade chassis. So
Mm.
you kind of look at the math. Well, it's 18 months between processors. That means I need a chassis life cycle of at least 10 years. So when I'm doing the power supplies today, and the power backplane and the cooling, how does that all architect itself up and what does it look like in 10 years' time? And again, the team did a really fantastic job on this because I think Blade System lasted more than 10 years, which is really good. So I was doing a lot of that stuff. And then um, eventually ended up at Cisco doing UCS, very, very much the same thing, chassis product
Mm.
management, power product management. How do we make all of this stuff work together from a data center perspective? Went through multiple years there, moved into Lenovo as the market kind of changed. One of the joys of working in IT is that eventually you're going to get laid off by somebody. um,
Okay.
And I did. So I got laid off from Cisco,
Okay.
um, and I ended up moving to Lenovo. That actually brought me into the North Carolina, Raleigh area because that's where their headquarters in, where I was doing a lot of work on hyperconverged stuff. Developed a lot of relationships with the people in the hyperconverged space because Lenovo never really wanted to do its own thing. It was very much we're going to do, Nutanix, we're going to do Microsoft, what used to be Azure Stack HCI. Then we'll be doing VMware vSAN. So
Mm.
working as a partner with all of those vendors and trying to drive the products forward and make them the best products on the market to deliver a hyper-converged solution, and a lot of work in that environment. So, and then, how did I get to Gartner? Well, I think it was Andy Butler and George, oh, I can't remember his second name, and I should be able to remember it, resigned. They were looking for someone who worked in the server area, and I had a friend who already worked at Gartner, and he phoned me up and said, "This would be the perfect job for you."
Okay.
And I'm like, "Gartner analyst? Me? Really?"
I mean,
Or,
yeah,
oh, okay. Um, so I applied. Um, Went through the interview process, which is long and arduous. They're very, very
absolutely.
focused
I can
on
imagine. Yeah.
making sure that you can deliver once you get there. Although they fully recognise that a huge chunk of the people that interview with Gartner have never been an analyst before.
Hmm.
So they know that they're going to have to train you to be an analyst. What they want to make sure is that you can do all the rest of the stuff, talk on your feet, because you're going to spend a lot of time talking to end users. In fact, common mistake people make about Gartner is that they think we spend most of our time talking to vendors. I don't. I speak to more vendors than a lot of other Gartner analysts, and I only spend 25% of my time talking to vendors. The other 75% of my calls are end user calls. I talk
Okay.
to end users all the time about what they're doing, how they're doing it, what they're interested in, where they want to go. And we spend a lot of time, and that's one of the real big focuses at Gartner is on the end user and how do we provide value to end users, which we can then translate into value into manufacturers and vendors. But the real focus is if we don't do a good job servicing the end user, we haven't done our job.
Yeah.
And that'll, you wanted to talk to me about magic quadrants later on, and that's one of the things that's really important there is end users really value independence and the ability to, quite frankly, annoy vendors at times.
Okay.
And
All
I do
right.
hope nobody from Gartner is listening to this because they'll probably get upset.
Right, I'll pick your brain on this right after this question. So, I want to, build some hype around what Gartner really is, what Gartner has really done, and how Gartner has come to be known as the definitive authority for enterprise IT guidance, right? Could it be development of, signature frameworks, like we just said, magic quadrants, the hype cycle, high touch advisory services, together, we've seen like how they form a decision fabric that really a board of executive leaders truly understand, right?
Mhm.
And this has really cemented Gartner's role as the go-to organization for world's largest enterprises. Could you like take us through this evolution of how Gartner has, become this authority for truly reliable for some of the top enterprises of the world?
Actually, my boss would be able to give you much more history than I can because
Yeah.
he actually worked for with Mike Tuber's my boss. He actually worked for the original Gideon Gartner, um, and could give you like a lot of history about that. Certainly, from my perspective, when I
Yeah.
joined, Gartner's been around for a long time. I've been here for 7 years, I think. Um, the big thing that really defines Gartner. There's a couple of them. One is we are genuinely vendor independent, as in, I have to pay my own flights. I don't like me personally. Gartner pays my flights and my hotels when I go visit conferences. We don't take money from vendors other than, strictly as a commercial relationship, you buy the service from us.
Hmm.
So that's one thing. And end users really value that vendor independence, that we can go and challenge a vendor, that we can ask all the questions that they would like asked on their behalf. The other thing that really I find inside Gartner is absolutely unique and it's more like a research organization or a university, is we do peer review and it's serious peer review. When I write a paper, I have to put it out to 4 or 5 other analysts who are all gonna go through it, and some of they'll go through it with a fine tooth comb and make sure that what I'm saying makes sense, and more importantly, I can justify it. Um, that I have some grounding to stand on to say, yeah, this is an opinion in some
Mm.
cases, but this is an opinion that's backed up by these facts, and here's the logic train that got me to that opinion, and it's not just me picking random crap out of the air. I'm actually basing this on stuff, and I have to be able to justify myself in front of my peers, who are all very, very smart and great Gartner analysts, and in many cases know more about some of the subjects than I do. You know,
Yeah.
there's a bunch of
Yes.
people I have to go and ask advice for if I want to if I want to know certain things, and that quintessentially. It is how we end up with stuff like Magic Quadrants, where, it's a very defined, very clear process on how we go and collect a bunch of information from vendors, um, and then analyze that information and then try and translate that into something hopefully that is relatively easy and simple to understand and that can be used, in that classical diagram where you can say, look, there are people who are very good at execution, but we're not their roadmap needs a bit of work, and there's
Yeah.
people who've got a really great roadmap. They really know where they're going, but their sales execution needs to come up, and then we got some people here who are great. And then, the classic mistake not every client makes, but any Gartner analyst will tell you that the classic mistake that people make is they look at the top right-hand quadrant, the leaders. And every vendor wants to be in the leaders quadrant because of course
Mm.
you do. That's such is life.
Yep.
But there are people in the niche quadrant. Niche isn't bad. Niche just means you might not do everything, but you could do one thing really, really well. And if that one thing matches up to a particular client's need, maybe you should be looking at that vendor in the niche quadrant. And that's one of the advantages of talking to us is, when you get we'll take you through that magic quadrant thing. So when you're looking for a particular vendor, it's not that we're saying, "Oh yeah, you absolutely have to buy someone in a leaders quadrant." It's no,
Yep. Yeah.
what's right for you? What are you looking for? Actually, no, maybe you should look at this vendor because they do your thing really, really well.
Absolutely. And if a CIO, have tracked only one magic quadrant to steer infrastructure and AI adjacent investments, how and which would should they pick, and how what would make it very decisive for a portfolio planning for them?
You can't really pick one, because there isn't one. It's,
Hmm.
where are you? What are you doing? If you should you be looking at the store, if you're looking at storage, maybe you should be looking at the storage Magic Quadrant. If you're in the networking space, the enterprise networking Magic Quadrant or the SASE Magic Quadrant.
Hmm.
There's magic quadrants for lots of markets. And the important thing there is with markets is that markets evolve and markets change. And we do try and have a mechanism for handling that evolution and change. So,
Yeah.
first thing is we have market guides. Not Some people miss out on these, but a marking guide, there's two types of market guide. There's an emerging market guide, which is, hey, we think this is a market. Here's a reasonable definition of it. Here's some companies we think fit in this market, and it may go away or it may carry on. That market might emerge into something big. If it does, it shifts up to a magic quadrant. And there we can start analyzing the vendors, who's competitive, who's not, what are they
Hmm.
doing, put them in their various quadrants, and yeah, still look at visionaries, look at challengers, look at niche, not just the leaders. If anybody's listening, if you take one thing away, take that away. Uh,
Yes.
But then markets mature. So one of the things I work on is the market guide to servers. This, God, a server Magic Quadrant would be tedious.
Yes.
It's just like, what are you going to put on there? How would you put stuff on there? It's not relevant in that in that kind of environment. So what you can do with this that kind of thing is bring that down to what we would call a late stage market guide, which really just talks about the server market and here's some vendors who play in that market. But we're not going to do detailed comparisons on them because it wouldn't be worth it, and quite frankly, you could go and get the information from our market share figures because I'm not going to tell you the leaders on market share in the server market are
Hmm.
probably doing a pretty damn good job. It's like, yeah, they're doing a good job. So that's one of the big things. And then, hype cycles, again, a really useful one, just to track where the world is with particular technologies.
Hmm.
Um, and a hype cycle is really supposed to be a measure of excitement in the market.
Okay.
Not necessarily is this a good technology or a bad technology? It's a technology and people are excited about it, is what you're measuring. And again, it kind of follows a flow. And I can't remember the lady who originally developed the hype cycle, but you could find it on Gartner's website. There's a flow, a natural flow of technologies with hype. You start off on the edge, this side of the curve, which is the introduction of this new technology. It hits the peak of hype where it's gonna solve world hunger and do everything.
Right.
AI and quantum are right there now.
Okay.
Uh, and then it drops down into what we call the trough, which is where and actually, I was talking to a vendor about, dropping into the trough, and that particular vendor said, "We're not worried. Actually, that's a good thing because what it means is that people are starting to figure out, no, it won't slice bread.
Hmm.
This is a technology just like every other technology. It has uses. It doesn't have uses. Falling into the trough it just means to figure out people are figuring out the real use cases." And if you make it into real use cases, you then get to the plateau of productivity.
Absolutely.
Which is where, the it's I pulled hyperconverged from the compute hype cycle this
Mhm.
year because it's on the plateau of productivity. Is hyperconverged a hyped technology anymore? No, it's just, one of those options that you could pick to put in your environment to deliver infrastructure services. You might choose that, you might choose three-tier storage, you might choose cloud, but they're all valid technologies. But none of them are particularly super hyped at the moment.
Right. Right. And would you say agentic AI, right, is one of those technologies making
Oh
the
yeah,
hype cycle?
that's right there on the peak of hype. That's not just, and again, don't make the mistake of thinking just because it's on the peak of hype, it's not going to be useful. Uh,
Okay.
It could absolutely stuff like agentic AI could become very, very useful. It's just, everybody's telling you it's the answer to everything at the
Yeah,
moment.
at the moment. Yeah, at the moment.
It's like, no, it's not actually going to solve every problem. Will
Yeah.
it solve some problems? Will it be a good tool for certain things? Oh God, yeah, I think really it will. But some of the stuff I've seen marketing about agentic AI is just, oh, for God's sake, no, it's never going to do that.
But again, how would the hype
Yeah,
re-
exactly. With the
go?
hype, you put it right up there.
Absolutely right. All right. So let's move into the Gartner's IT Infrastructure Operations and Cloud Strategies Conference
Hmm.
that you will be speaking at this year, right, in December, I think, in Las
Yep.
Vegas. And yeah.
Actually, I mean, there's four of them. So and you're going to make me look up the dates now. But there's Europe, which is in November. So
Okay. Yeah. Yeah.
anybody who's in Europe, we run that conference in London. It's similar content to the one
Yeah.
that we run in Las Vegas. Um, and we're in the Excel in London. So do come down and see us there. For our Japanese users, we have one in Japan as well.
Okay. When's
And
that?
then uh, now you are going to make me look. And yes, I should have written these um, down beforehand. It's the 2nd to the 4th of December.
Oh, right.
Um, so, that one's in Japan. So anybody in Asia Pacific, there's a great set of sessions there in Japan as well. Later on next year, we will have IOCS in Sydney,
All right.
Australia. So content there as well. And
My God, you're speaking at all of these.
no, no, no. I
Okay.
I have actually spoken at all of them, just not necessarily this year. Um, so I've done the Japan conference. I did it last year. I've done the Australia conference a couple of times, and I will be speaking at both EMEA and Las Vegas this year.
Awesome.
So, and the EMEA one is on the 17th to 18th of November in London.
Brilliant, brilliant. So I was, looking through some of your speaker points, and I really wanted to bring this yeah, one topic, that's been really in the discussion lately, which is data center energy and the future of data centers, energy shortages, efficiency, and AI. Right, with the current breakness pace that we're seeing, the deployments, of these models and all that. Right, the future of data centers becomes a very critical topic right now. Right. Uh, what practical frameworks do you think should executives and leaders guiding the decisions should use for site selection, right, design and operations, when I'd say power is the constraint, should
Yep.
be the constraint rather than an afterthought?
Oh yeah, and that's the big change in the market. Site selection principally used, a lot, but there was a lot of factors that went into site selection. It would have been, in the past, it would have been all about things like natural disasters. I don't want to put my data center in a floodplain or in a
Mm.
hurricane zone or in a tornado zone. There's good reasons why I wouldn't want to do that. Then, still a big limit is location of fiber. So, but more importantly, back in the day, say 5, 10 years ago, a lot of that was around fiber latency. So, how close am I to a major internet exchange? How many milliseconds am I away from Chicago, New York, or, Virginia, where the cables come off for the Atlantic, that kind of thing. So there was a lot of interest in latency. Now it's more a case of bandwidth.
Okay.
One of the things AI has changed is I don't for a training model, I don't really need latency. I just need the ability to move data in and out at fairly high rates of bandwidth. Now, inferencing will kind of switch back to latency, but we're not quite there yet. Um, and a lot of things around power as well, but it wasn't the biggest issue. Now it's all about power.
Yep. Yep.
It's can I get power? Um, Things that never would have come up before, like where's the nearest natural gas pipeline?
Hmm.
It was like, what? You'd never. Why would you place a data center near a
Yeah.
natural gas pipeline? That's
Yep. Yep.
that's actually a threat. That something could go wrong with the pipeline. Well, nowadays I want to be close to a natural gas pipeline because I'm likely to want to do local generation of some kind. I'm gonna need that natural gas to run generators or run power on site
Yep.
so that I can run potentially without the utility, because the utilities now are getting so overloaded that they can't provide connectivity anymore or can't provide it in a reasonable timescale, because people aren't asking for 10 megawatt data centers, they're asking for 100 megawatt data
Yep.
centers. So maybe I can get 50 megawatts and put 50 megawatts of natural gas generation on. The other reason I want to do that is because the power characteristics of AI are very different from the power characteristics of a traditional data center. A traditional data center doesn't really go up or down much in terms of power consumption,
Hmm.
over the course of a day. It might go up over 6 months as people bring more stuff in, but over the course of a day, there's no, significant fluctuation. Whereas if I've got a giant training cluster,
Hmm.
that giant training cluster that's maybe pulling several megawatts of power can go from 100 kilowatts to several megawatts in seconds. And if it stalls for any reason and stops, it'll go from several megawatts to nothing
Yeah.
in seconds,
Yep. Yep.
which utilities don't like that. You know, that is very significant amounts of load being very, very highly variable load being placed
Yeah.
on the utility. So you have to figure out a way around that, and that's going to be done at least partially with some on-site generation, um, big batteries, so
Hmm.
you can absorb some of that rapid power change and not have it all instantaneously relayed to the utility. So there's a lot of interest and changes in the way that data centers are being designed. So, fundamentally, things like site selection are really, really changing to what's the power availability like and what could I do for on-site generation and what can I do for on-site energy storage in that particular environment. So some real big changes to data center designs. And then on the inside of the data center, everything's changing as far as cooling goes.
Hmm.
Whereas previously everything was air cooled. And I'm talking to people who are talking about, hey, we currently run our data center. We can maybe run a 15 kilowatt rack. It's like, well, that's not going to do any good anymore. Um, you know, a You're probably looking, even if you go with air-cooled, DGX servers from NVIDIA, you're probably looking at 40, 50 kilowatt rack.
Yeah.
If you really want to implement NVL72 style solutions, those are 120 kilowatts per rack and liquid cooled. So
Right.
you now have to redesign your data centers around, well, we're going to be doing some form of liquid cooling in these environments, and it's going to be probably direct to chip. So, a whole big world of change around what the data centers inside look like, and then everybody at the moment is also looking at the roadmap of to where we get to, which is yeah, we're 120 kilowatts today. The next generation, or I think maybe 2 generations away, they're talking about 600 kilowatts in a
Yeah.
single rack. That was an entire data center hall 10 years ago.
Yeah. And 5 years from now, how do you see that accelerating? Because the current deployments and the need for integration of these systems, uh, the need for data centers keeps increasing and increasing. And I was reading these reports like the next 5 years. I'm not saying 10 years. The next 5 years, there's going to be some issues and discussions around the shortages, energy shortages.
There will be, although there's a lot of work going on right now where the u the ut the power utilities, and there was some very interesting research done by a gentleman at Duke University,
Hmm.
um, that actually looks at the grid and says, "You know what? There's actually only relatively few periods of time when the grid is at full capacity." And
Okay.
generally, think summer in Texas
Uh,
when it's, 105 degrees outside,
yep.
everybody's running their air conditioning flat out.
Yeah.
Um, or, correspondingly, a winter storm in Texas, like what happened a few years ago, where everybody's trying to run the heating flat out. That, other than that, the grid probably runs at 50-60% capacity. So there's actually plenty of capacity around, as if you could move workloads or
Hmm.
curtail, what they call curtail workloads, which is, the utility sends you a signal to say, you know, it's 105 degrees outside. We're going to need lots of power for air conditioning. Please turn your workload off.
Absolutely. Yeah.
And of course, if it's an AI training workload, that's actually not an unreasonable thing to do. Now, okay, yeah, if it's your order processing system, no, you're not going to turn it off. But there are definitely workloads that could be curtailed. So there's a lot of interest in and around that. And you've already seen some announcements. I think Texas did SB6, which is a piece of legislation that starts to require this. Google made a number of announcements about they're really looking at how do they do curtailment for their AI training workloads, because that's and because it's also a fact that the AI training workload is going to shift megawatts of power, whereas me turning off my order processing system is 2 kilowatts, big
Hmm.
deal. Um,
Yeah.
so who cares? So there's some work being done about in ingenious ways of fixing this problem. So it's not it's not as bad as it's made out to be, because there's a lot of predictions that kind of assume that, oh, that 150 megawatt data center is actually going to use 150 megawatts 24 hours a day.
Hmm.
It's not. It just doesn't. It's going to be up and down and variable, and maybe you could turn the workloads off. And so there's a little bit more flexibility in the system than reality, than people really realize. The other really interesting thing is when you look at all the requests, and again, Texas SB6, really good piece of legislation that people should take a look at. One of the things that they require on that is that any request for connection, you have to identify to the original source. Because what's happening at the moment is a company says, I need 100 megawatts.
Hmm.
And they go around to a bunch of brokers, and all of those brokers ask the utility for 100 megawatts. So what happens is the utility sees a request for 500 megawatts, but it isn't. It's actually 100 megawatts.
100 miles.
So again, so there's a requirement in there to stop people from doing this, so they can get a real read on what the actual power requirement is, as opposed to this fake market signal we're getting at the moment is because there's 10 people all requesting the same thing.
Yeah, absolutely.
So it's going to be fun. And the biggest thing you're going to find if you want to build a data center today is it's going to be expensive. And your lead times are going to go through the roof, because everything is on a huge lead time at the moment. Connection to the utility is on a huge lead time. Um, it's not just the generators and the UPSs and the cooling equipment, which is all on 2 or 3 year lead times. It's boring stuff like, can you find an electrician?
Okay.
Because why? Because Amazon, Google, Microsoft, all the big boys in the data center space, they've got all of the electricians working for them on
Yep.
their data centers.
Yeah. But still, I'd say, the next few years, this is going to be a very interesting turnout to see.
Yep, it's going to
Yeah,
be fun. It's definitely going to be fun.
absolutely. All right. So now I'll move into a bit of something that requires somewhat of your advisory skills, right? Talking about enterprise architectures, right? And for say AI first delivery, right? Now, enterprise architectures, they create the leverage when data, APIs, and AI services are treated as productize infrastructure, right, with clear contracts and ownership, right?
Hmm.
That shifts EA from documents to a proper operating model, right? What do you think? What does a product-aligned, cross-functional EA model looks like when data, API, and AI services are treated actually as foundational infrastructure, right? What shifts help it work?
So yeah, there's some interesting ones there. The it's going to become much more of an SLA
Hmm.
um, solution rather than, or maybe a service level objective rather than a service level agreement. But the big change in enterprise architecture, and I've, I'll keep this relatively short,
Hmm.
is that the change is going to be you're going to be moving towards a more contract orientated world where, because there's going to be multiple agents operating in this environment, so we talked about the hype around agentic AI, but this idea of an agentic AI agent and having multiple agents talking to each other, how do you that's how do you do that? What do you need to make that happen? I don't mean at the protocol level. That's
Hmm.
bits.
Hmm.
I'm thinking more at, how do these AI agents agree with each other, what they can do, how they, not necessarily how they do it, but what services can they provide and what kind of capability can they provide and in what timeline. So it becomes a contractual thing of, what's my SLA between these agents? So if I have an agent that wants to go out and request a particular set of services from the architecture, what's the SLA that comes back and says,
Hmm.
okay, you wanted X, Y, and Z, I can do X, Y. You need to talk to agent Q about Z, and I can do X and Y in these time frames. So it becomes, oh, it's going back to promise theory. We could see the revitalization of promise theory, um, of, you have two agents operating, and one agent makes a promise to the other agent, I will be able to deliver this service to you in this time frame or within these bounds. So yeah, it's going to be interesting. It's I won't necessarily say it will go back to pure promise theory, but I suspect something like promise theory is going to come back in.
And do you think enterprise architects, can operate as strategic advisors at the infrastructure layer, right? So that their work can change the outcomes.
Oh yeah, and they should be part of that design. There's a lot of discussion around at the moment, of, should I replace VMware? People are looking at what's happening with Broadcom, and there is a
Mm.
discussion as around, should I replace the VMware with something else? That's, you're asking well, not necessarily asking the wrong question, but one of the people who absolutely needs to be in that room is the enterprise architect. When you're asking that question, why? Because you're making an enterprise architecture decision about the infrastructure, the fundamental underpinnings of everything that the enterprise architect is delivering.
Yeah.
And you should not be making that decision independently of where the enterprise architect is going, because that's gonna turn out really badly if you do
Yeah,
that.
absolutely. Yeah. And my second last question, would be, so this is very, I'd really like to pick your brain on. It's about, building global talent, at scale. And now global delivery, it's no longer a cost strategy only, right?
Mhm.
It's now seen as a resilience and time to value strategy, especially as AI and data work stretch teams. How do you think executives and leaders should tap emerging hubs, especially across the global south, right, to improve speed, to improve resilience, without losing cohesion or customer trust?
So, I'm gonna defer here,
Mm.
and the reason I'm gonna defer is that there's a bunch of people inside Gartner who are way more qualified than I am to answer that question. Um, we have an entire talent team who focus on this kind of stuff, and
Mhm.
actually to blow the horn for IOCS just a little bit. One of the things that we offer you at the global IOCS conferences is access to those people. So even though we call it infrastructure operations, or the Infrastructure and Operations Conference, or Infrastructure and Operations and Cloud Conference, it's
Mm.
also about leadership. It's about talent. Where do you go get these people who can do this kind of stuff? So, an area I'm not 100% on, but that's the advantage of Gartner is that if I can't answer the question, I can find you someone who can.
Right. By the way, which would you say which work fits latency sensitive versus distributed teams?
Um, so that's a really hard question because your instant response is, oh well, if an end user wants to talk to you about it, but hey, I've got a phone, we're on Teams,
Yep.
we don't necessarily have to be in the same region. Why does that become latency sensitive? So distributed team, I mean, and I work in a distributed team. Um, I worked on the strategic cloud platforms, Magic Quadrant, and we have people in China, we have people in Europe, and I'm in the US. So we have a bunch of people spread all over. I don't know that there's particular work that can't be done by distributed teams.
Hmm.
Now, a particular knowledge work that can't be done by distributed teams. Now, if you want to get into the physical world, then yeah, you need someone local to connect up the wiring in your data center.
Yep.
Yep. Yep. If my data center's in India and my people are in Sri Lanka, that doesn't do me a lot of good. Um, so there's physical stuff that has to be done there. The other um, things that aren't necessarily best for distributed teams and again, it really comes back to the physical world.
Mhm.
If you're dealing with something physical that can't be communicated easily electronically, then
Mhm.
having a co-located team is a big deal. I'll give you a very specific example. I've never done board design, but we used to have a bunch of people at other companies I worked through did board design and debugging. There's really nothing quite like being able to put the same bunch of people in a room with an oscilloscope, a logic analyzer, and the people who are writing the firmware to figure out what the hell is going wrong with that system.
Yeah.
Um, then physical co-location becomes a lot easier. But there's some stuff you can do around that with modern teams as well. As we're talking on video. There's a lot you can do with video. There's a lot you can do with chat. Um, there's a lot that can be done um, as long as you can get people on the same communication mechanism at the same time. And that's the problem. Is some it always ends up with somebody staying up late or getting up really early.
Right.
Time
Yeah.
zones. They mess everything up.
Yeah, no argument against that. All right. All right. So just to finish it off, one final question, I'd say the uncomfortable prediction. The best leaders, place a few informed bets before the consensus arrives, right? What is one 2030 level prediction, about enterprise infrastructure that you believe now? And what early signals should CIOs watch to validate or falsify it?
So there's a couple. The big one and obvious one is quantum computing
Mm,
because once the quantum ability of quantum computing to break existing security algorithms, once that happens, everybody's gonna be in a world of pain, and people need to be preparing for that now because when that happens, everything that you've got encrypted today becomes decryptable unless
Yeah.
you've already encrypted it with a quantum safe algorithm. So you've got all these encrypted backups and encrypted data and stuff like that. You need to convert it and you need to be thinking about how you're going to do that now and how you plan to swap out your algorithms over time. Um, the other big elements, things like energy efficiency, although, I've been talking about data centers and what's happening there,
Hmm.
is people are going to get a lot more interested in energy efficiency for two reasons. One, because of the impact on AI on the grid. And I didn't mean to minimize that if I came over that way because there is
Yeah.
going to be an impact. But also because if you're running a 100 megawatt data center, your electricity bill is huge. It's
Yep.
just no two ways about it. And it's the kind of number that the CFO gets interested in. And they will look at it and go, what can we do to help reduce this? So you're going to see a lot of interest in energy efficiency. And some of that is going to flow to architecture. How do I design this system to be more energy efficient? Some of that's going to go right down that to the developer level
Hmm.
where, is the language you're using the most efficient way to do this? Because has a huge impact on energy efficiency. How can you make this more efficient? And that's not just being driven by sustainability, or sustainability will be part of it. It will just be pure money as well,
Hmm.
because the bill's big.
Absolutely. Yeah.
So,
For one thing. Yeah.
from a developer point of to make a prediction, um, energy efficient programming languages, I think, are going to be a thing.
All right. And how soon do you think that you see that happening?
Uh, Probably in the next. I would push that one out probably to 2030.
All right. All right. Let's see. Well, Tony, thank you so much for taking out the time for doing this, and your insights have been really great into especially the future of data centers, the architecture, theory of enterprises, and really excited to see your sessions as well on the upcoming conference, Gartner's conference as well. I
All right.
really hope to have you soon. Join us again.
All right. Thank you. Have a great rest of the day.
You as well. Thank you so
Thanks.
much.
Bye bye.
Bye bye.